Alright, so I did some off-camera work on the build system, so now it's a dynamic library and it should actually install properly as a header. Oh yeah, and I added package config, which is kind of important apparently. Alright, we're now working on integrators today since I forgot I neglected the simulation class, so I'm gonna work on that today. Alright, okay. As we can see, yeah, I only so far implemented the stuff that would, kind of essential for things to not crash. So, yeah, this is not good. Yeah, we're going to continue some work on this. Enum, yeah, right, no. I have an integrator enum in the config, but I never actually set it. Well, yeah, I guess I'm just gonna do this. I'm just gonna put this whole section in the private. So now I can just put in an integrator enum class tag. Oh wait, no, this should not be here. The integrator should not be here. Should be integrator type. And let's set it to by default integrator Yeah, let's set it to leapfrog for now. That's like a terrible default, yes, but I haven't even implemented WH fast yet. And no integration is definitely not a thing you want most of the time, so leapfrog it is for now. But yeah, the setting errors. But it can set it here. Can't do that. Should I just make a class? Let's just make a class for this. I'm too tired. I have to do some weird trickery. Integrator type. Yeah, why did I put integrator? Did not call it integrator type, but I'm just gonna call it. Just delete this whole section. Class. Integrator. Integrator config. I'm just gonna put integrator config. That's gonna be the name. Private integrator type and the format integrator type. So we have leapfrog, WH fast, IS15, IS15, and Mercurius. Not capital Mercurius, normal oh my god, Mercury. Fine, it's gonna force me to do that. If my text autocomplete here won't do that, I'm just gonna do it manually. Oh yeah, this is all in a union. Alright, so that's the union that done now, so. Public. So, yeah, I think I should probably use instantiate like so. So I'm just going to do this as integrator config with integrator type yeah. Oh yeah, and we're gonna have to do it. You can't initialize it in there because we have to check this. So now let's just add a struct called no integration. That is quite literally nothing. just so I can add it in here. And it's gonna be a useless parameter. If yeah, I've been coding in too much Rust, I keep forgetting the parentheses around. If type equals integrator type none, let's do none first. Equals no integration. Else if type equals integrator type leapfrog. Alright, so I did some basic API for the integrator config class. And now I'm gonna make an instance of it. Oh wait, I forgot to add assignment. Alright, so instead of doing that, I just made a bunch of implicit constructors. I guess I'm just gonna mark this explicit, and I think this is good. Alright, so now we actually get to work on the function. Not the function, the simulation class. Yay. This Yeah, all of these have already been defined in earlier episodes, so I think we're fine on those. The thing we're gonna have to do here is not cry. Think. Alright, so if we assignment, yeah, first off we're going to have to just give it a thing. Yeah, we're gonna have to give it a public member that's an integer config. I'm just gonna eventually just move this whole thing down to public so I can be more concise. And we're just gonna call this config. Yeah, let's just call it that. So now we are going to add some integration. Void step. Yeah, we're still gonna step function in here. I don't think we need any parameters per se, but we make sure. I don't think we need any. Step. And then I think all we do here is plain simple running the integrator. Yeah, I'm gonna need to add like a is type function in here. That's gonna be kind of important. So bool is type integrator type bool type. Let's call it type. And it's just gonna be a trivial return type. If config.type equals integrator type leapfrog, we're just going to run step on that. Config.get leapfrog dot step. So particles, and I think we're just passing a DT, which we already have in there too. Else if config.type. Oh my god, why I'm still using these? We have switch cases here. Forgot about switch cases. Let's just continue working on what switch cases. Config.type case integrator type leapfrog. I think all we do here is literally exact same thing we did when we went into if statements. We just get it as the reference and then step with it. This is trivial. And that reminds me, I still forgot to add one that's const. This should be a trivial one to add though. I'm just gonna yank this. Const. And I think we need to just get const. I just guess. I'm just gonna put the get. Or, yeah, I could mark this as const actually. That's. Yeah, that looks good enough. And I think that's it as far as that's concerned. Config.get as a with leapfrog. Or wait, don't just static assert to here and don't do that. Alright, step is done. Now on to steps, which is very similar. I just have to add a loop onto this and add a loop. Or I could just run an actual loop and just call step 1,000 times. Size tn. Step. Void integrate, and it will run until it goes over the limit. Unless you choose an exact, then it's going to do so. Or I'm gonna show this on screen because it's kind of interesting still. Void integrate double T. Status. Yeah, this is where status is considered. If it says term, which short for terminate, then it'll terminate the whole integration. So it's going to be double T and oh yeah, and if you do exact, it'll run exactly until it's there. Equals false. while t is less than t. Sorry if these sentences are confusing. Status equals what is it? Equals heartbeat. I'm just gonna do this. If I don't, unlike Rust, we don't have like a debug, so I'm just gonna have to make do with my status in them, which let's just do void status to string. Not void, this has to return something, obviously. Should I return a string view? Yeah, let's just return a string view. I forgot D++ doesn't have Rust expression capabilities. I'm just gonna have to do standard string view res. Switch, what's the property here? No, there are no property, so it's a return thing, so there's no property, so status case status term, you just return term. And then just the default, I guess, is just going to be returning an empty string. So if the status is not okay, then we just do. Okay, yeah, probably should move this stuff into a source file. I'm gonna do that off camera. Alright, everything has been moved to the CPP file other than steps, which just is still in there. I think that's fine. So, yeah, okay. So, I will eventually make a proper logging class. For now, I'm just gonna put like something like that. Okay, good. Alright, so that has been basically not completed yet. Hey, at least it works now. So, that's amazing. This, yeah, we're just going to step. So, yeah, I already dealt with the heartbeat first, but we're gonna have to do stepping first, though. First, we step. Alright, so step. I think I'm gonna update steps likely to taken at DT. To account for standard max. I don't want actually standard max. I'll just use DT DT is less than T minus T. If so, we use DT. Otherwise, we use T minus T. Double step size equals, I guess I'm just gonna use that expression. T minus T, DT, T minus T. Alright, so, and now I can run step size. And increment T by step size. Okay. Wait, I have an idea. Nested. This is gonna be amazing. Nested turn expression. I know, a bit controversial, but it's interesting, so I'm gonna do that. So alright, so I'm just gonna do step size exact. If so, you then do this check. Otherwise, you just turn DT. And I think that's it as far as that's concerned. Oh yeah, and I do have to update the thing here. Double DT, step, DT. And now there's this warning. I'm gonna deal with that now before it bugs me more. DT other dot DT. Come on, where is that? Oh yeah, it's somewhere after all the private particles. Is it after config? Yeah, I think it's after config. Okay, now that warning's gone. I sure hope this code does not fail whatsoever. I'll add saving to a file later in a next episode or something. For now, I do want to focus on the actual algorithms. So yeah, I think we're done here for now. Does it work? It probably should. I'm just gonna make all the unit tests run with simulation, and if that's clearly an error with simulation, since all of them were working beforehand, so I'm going to do the unit test off camera too, and no matter if they fail or succeed, I'm still going to end it after that. Alright, I still need to add features to add particles. Yeah, I'm just going to deal with that tomorrow. I don't want to continue doing this today, so see you later.